Could you hear me? Sir, Anup sir.
Yes, sir. Good afternoon. I can hear you.
Good afternoon, sir. I welcome you to the portals of AICTE at Alagappa University.
Thank you. Thank you so much, sir. Thank you so much.
Yeah, so you can check whether the PPT is getting displayed in the Google Meet or.
Yeah. Let me share my screen, and could you please check, is it visible?
Sure, sir. Sure. Yeah.
Yeah. Okay, let me give 2 seconds. Is the PPT visible, sir?
Yeah. Now you're presenting. Let me see.
Yeah. Is it visible now?
1 minute, sir. 1 minute.
Yeah. Sure.
Yes, sir. It is visible.
Okay. Okay. Fine. Cool. I mean, my voice is clear as well, right?
Yes, sir. Your voice is very clear.
Okay. Okay.
Dear participants, within 5 minutes we will start the session. Let us wait for 5 minutes. Let the participants come and we will start the session. Here there are some general instructions to the participants. Good afternoon to all the participants and resource person. Since we are in need of 80% attendance, if the participants are in need of a certificate from the AICTE, it is mandate that they should have a 80% of attendance for all these 5 days. So please ensure that you are having 80% of attendance for the 4 days. And at the end of the session, we will provide you 15 minutes of time for asking any queries, any Q&As, queries, and your clarifications. And the resource person will make you delighted with it. And I mean, the AICTE Atal is in rate of at least 5 participants' feedback. So I request you to provide the feedback. Thank you so much. Very good afternoon to respected dignitaries and respected resource person, Dr. Anup sir, and the participants who have gathered over here for the afternoon session. I welcome you all to the portals of AICTE Atal FDP, Blockchain in FinTech, which is being organized by Department of International Business, School of Management, Alagappa University, Karaikudi. And now let me welcome Dr. S. Karapalakshmi Madam to welcome our resource person and to give a brief introduction.
Good afternoon to all. Good afternoon,
Good afternoon,
to all.
madam. Good
It is
afternoon,
my
madam.
privilege to extend. Good afternoon, Sundar.
Good afternoon, madam.
It is my privilege. Good afternoon, sir. It is my privilege to extend a cordial welcome to all of you. Respected our Honorable Vice Chancellor, respected our Head of the Department of International Business, Dr. Muthuswamy sir, respected our faculty members of International Business and Research Scholars, all the participants, a very warm welcome to all of you. It is great pleasure to welcome such a noted personality, our resource person, Dr. Anu. He is currently working as the Assistant Professor in the Department of Computer Science at Rajagiri College of Social Science, Kochi, Kerala. Previously, he worked as a Senior Scientist and Training Head at the Kerala Blockchain Academy and also worked as an Artificial Intelligence Data Scientist, Artificial Intelligence Research Engineer, Research Partner, and Software Engineer in India and United Arab Emirates. He has also well-known experience and knowledge in the field of industry research and academia. He has worked in the areas of applied natural language processing, text mining, and information driven. Let me extend a warm welcome to you, sir. I thank to our Head of the Department of International Business, Dr. Muthuswamy sir, for giving me this opportunity to introduce our resource person in this session. Thank you, sir. Thank you, Ananda.
Thank you, madam. Now let me welcome our resource person. Dr. Anup sir, to take over the session. Thank you, sir.
Thank you, ma'am, for the wonderful introduction, and thank you, sir, for the invite. So a warm good afternoon to all the participants. A warm good afternoon to all of you, and I hope you all are fine and safe. Your loved ones are safe during these pandemic times. And it is indeed a great pleasure and privilege for me to be a part of this great FDP on AICTE Training and Learning Adult Online Faculty Development Program on Blockchain in FinTech. And thank you, the Honorable Vice Chancellor, all the administrative heads, okay, the teaching faculty members and the non-teaching staffs at the Department of International Business for giving me this opportunity. Okay. So as they have entrusted me with the duty of introducing you to the topic, the smart contracts. So in this session, we will be covering the what is smart contract, and before that, I will be giving you some generic introduction on why it is important to learn smart contracts. Okay, and I hope you all will be enjoying this session. And at the end of the session, we can spare like 10 to 15 minutes for the QA, so that if you have any doubts, we can clear that as well. Okay, so thank you once again for joining this session. Let me share my screen. Okay, I hope the screen is visible for you now, Sundar sir.
Yes, sir. Yes, sir.
Okay. So the session that in the coming like 1.5 hours that you will be hearing is on smart contracts, its definition, process, development. Then you will be seeing what is a solidity and some of the best practices on how to develop the smart contract. Okay. So this one that I already you have gotten information about myself, my background, and also I'm not going to repeat this. Okay, so before starting the actual session, let me this graph somewhere in the internet.
Yes, sir.
Okay, what is it? So it is known as, so for the participants, it is known as actually the Gardner hype cycle. So what is Gardner hype cycle, or forget about the hype cycle? Who is Gardner? So Gardner, for your information, it is the largest research and consulting firm in the globe. Okay, they are having many presence in almost all the countries, and in every year they will be publishing the technology trend in this form, in a graphical representation, and this is known as the Gardner hype cycle. Okay, and this hype cycle, if you check the terminologies over here listed out here, we will be having most of the terminologies which are familiar to us. At least we have heard the names, right? The knowledge graph, the autonomous driving, the quantum computing, the deep neural networks, the smart workspaces, so IoT, the blockchain. So these are the technical terms that will be included in this graph. Okay, so why they are publishing such a graph? It is just like a prediction that Gardner is saying these are the technology trends that you are going to witness, okay, or the technological advancements that you are going to witness in this year. Okay, if you check the y-axis of this graph, it is denoted this as the expectations. So these are the technology that are expected to be grown in this year. Okay, and if you check the x-axis, it will be having 5 sections. One is the innovation trigger, the peak of inflated expectations, the trough of disillusionment, the slope of enlightenment, and the plateau of productivity. So these 5 parameters depicting the different times. So how much time it will be taking for these technologies to become production ready? That is what the Gardner hype cycle gives the glimpse for us. Okay, so if you check, there are legends that you can see on the gray color will be taking less than 2 years to become the production ready. Okay, in the blue color it will be seeing 2 to 5 years, and in the dark blue it is denoting 5 to 10 years, and the yellow color that denotes more than 10 years. But if you check, I have highlighted certain things that will be here related to blockchain. The blockchain for data security. The Gardner predicts it will be taking 5 to 10 years that the blockchain for data security will become a production ready, or it will be reaching the plateau of productivity. Okay, there are blockchains that you can see in this color that it will be taking again 5 to 10 years. But this data is for 2018, that is 2 years back. Okay, since then the blockchain has become a key terminology in our daily life in many businesses across the globe. So in 2020, okay, Gardner has published a life cycle, Gardner cycle for the blockchain itself, where the terminologies related to blockchain only is showcased in the hype cycle. Okay, so there are, if you check on the rise, there are certain keywords and certain terminologies associated with blockchain, that is authenticated provenance, the blockchain managed services, decentralized web, smart contract oracle. There are many other terms, the zero knowledge proof, etc., that are on the rise. Okay, then at the peak, there are blockchain asset tokenization, consensus mechanisms, tokenization, decentralized identity, and most importantly, the smart contract. So these are at the peak, that meaning it has gained the momentum for the blockchain space. So learning smart contract or understanding smart contract or developing smart contract become very crucial, and the organizations are now implementing smart contract. Okay, and this report and this data that I have collected is from the Gardner report, which was published in July 2020. Okay, so Gartner Hype Cycle, initially they were publishing blockchain as one of the technology along with IoT, along with artificial intelligence, and they will be showcasing it. But I mean, due to the changing industry trend on adopting blockchain technology, that they have started publishing a hype cycle exclusively for blockchain, listing out the key terminologies associated with the blockchain. Okay, so they have published the Gartner blockchain spectrum. Okay, so what is Gartner blockchain spectrum meaning? There are, according to the Gartner, okay, there are 5 key elements, okay, associated with a blockchain. And if we need to say a blockchain solution is complete, then we need to have, or that solution should have, all the 5 key elements. Okay, so let's see what are those 5 key elements. The one element is the distribution. The second is encryption. The third one is immutability. Fourth is tokenization. Fifth one is decentralization. When all these say 5 elements are combined, then that will become a real blockchain, and organizations will be able to reap all the benefits of blockchain. But right now, whatever blockchain that we are working with or what we are developing comes under, they can only showcase any 3 of it. Okay, so most of the times the current blockchain solutions are showcasing the distribution, encryption, and immutability. So we need to compromise on some elements to make the other elements noteworthy. That was a current situation of blockchain. Okay, so the Gartner blockchain spectrum says there are 3 categories of blockchain. One is blockchain inspired, second is blockchain complete, and the third one is enhanced blockchain. So right now, from 2010 to 2020, the year 2010 to 2020, if you inspect, okay, if you check, we can see that the current internet is internet of content, because we are focusing on the content that are published into the internet. Okay, and there are other technologies such as semantic web that is taking a lot of advancement to make the computers understand the content by using the knowledge graph, the ontologies, etc. Those are the terminologies that we are trying to develop to make the computers digest the meaning. Okay, so that is the internet of content. But from 2020 to 2030, Gartner says the internet will be not just internet of content, but the internet framework or the architecture will be internet of value, because people will be using internet as a medium to transact value. Okay, so that type of blockchains are known as blockchain complete. Okay, so by 2023, it is expected that the blockchain complete will become a standard, so that the people will be transacting values through blockchain. And beyond 2030, we will be seeing an enhanced blockchain. Okay, enhanced blockchain meaning you are adding more and more features, more and more terminologies or technologies into the blockchain. So such as IoT. So your say blockchain solution will be interacting with Internet of Things. Okay, sensor data will be connected and will be collected and added into the blockchain, or else you are interacting with a robot or through artificial intelligence. So this is known as enhanced blockchain. Okay, is it clear? So right now we are working on the Internet of Content, and we are emerging towards the Internet of Value, and beyond that we will be going with the Internet of Everything, right? Internet of Everything meaning every blockchain, AI, IoT, everything is combined to have a complete system. Okay, and Gartner says the blockchain inspired solution is using 3 out of 5 elements, as I said, distribution, encryption, and immutability. By 2023, enterprise ready blockchain complete solution will emerge. This will utilize all the 5 elements. Okay, and moving into 2025 and beyond, blockchain will incorporate complementary technologies such as IoT, artificial intelligence, decentralized self-sovereign identity management, etc. Okay, so I believe these are interesting, right? The Gartner itself has expressed a lot of interest in taking blockchain as the future of technology. So it is very important and it is very interesting to learn what is this technology. Okay, so if it is interesting, let's dive into the details and see what exactly is blockchain. I know many of the previous sessions you were having the basics of blockchain, how blockchain works, the Bitcoin, the security, and all those things. So I will not be covering much of it from the technical perspective, but we'll try to make you understand by using simple explanations what exactly is blockchain. Okay. So when I ask you what is blockchain, these are the terms that probably that will be coming to your mind. Okay, so many of the times I will be asking these questions to many of the corporates or many of the faculty members where I will be conducting these trainings. They will be saying, okay, sir, blockchain is equal to Bitcoin. Or what is blockchain? They will be saying, sir, it is Bitcoin. Okay, sometimes they will be saying it is peer-to-peer database or new internet. They might have heard the term hyperledger, the decentralized applications, the chain of blocks, distributed ledger, Ethereum, etc. There are so many other terms that they will be mentioning. But exactly, blockchain contains it everything. Okay, but try to understand blockchain is not equal to Bitcoin. That is important. At least you should be in a position to distinguish between the blockchain with the Bitcoin, because the Bitcoin is the cryptocurrency and the blockchain is the underlying technology. Okay, so Bitcoin is a cryptocurrency and Bitcoin uses blockchain as a underlying data capturing platform to securely record the transactions in a tamper-proof manner. Okay, so let's dive into those details. So in conclusion, if somebody asks you what is blockchain, you can simply say it is a distributed ledger technology. I repeat, blockchain is a distributed ledger technology. So I will ask you one question. What is a ledger? Have you heard this name ledger before?
From accounting and finance.
Yes, exactly. The ledger is not a new term, right? The ledger has taken its place, okay, from the early beginning when people started some businesses. People started transacting something, okay? So one basic example that I can say is like the best person who will be keeping a ledger always is our mothers. Okay, so mothers will always be controlling the complete budget of the home. Okay, so for example, if there's a person who will be giving the milk, okay, or else there is a person who will be selling the vegetables, the mother will always record that, okay, I have given 100 rupees to the vegetable seller on this day, but he has not returned the balance 50. Okay, or else if he is giving some money to the neighbors, okay, for lending some money or something, then obviously she will be writing everything. Similarly, she will be preparing all the list of things for a complete month on a piece of paper or on a book. Why she should do that? Why she should do that? Because to keep track of what has been done in that month. At the end of the day or at the end of the month, she will be calculating, she will be summing up all the amounts and then she will be writing the balance, so and so, right? So that is the one best example of a ledgering mechanism or people keeping ledger. But ledgers are, you can treat ledgers as a physical register. Okay, in earlier days, the people were using printed, the papers, and they will be writing those transactions in a chronological order. Okay, chronological order meaning the order in which it has happened. Okay, so there is a financial, organization which is lending money to people. Okay, some people came in asking for some money for say 10,000 rupees. So obviously, before giving the money to that person, it will be recorded on a ledger saying that, okay, this person has came and we have given 10,000 rupees to him. Okay, after 3 months, he comes back and pays 15,000, say 5,000 as an interest. Okay, so that also be recorded. Okay, and there is multiple ledgers that are, or multiple records, or the registers are kept in an organization where writing all the transactions. And at the end of a financial year, you might have heard the term audit. What is audit? reconciliation, right? Checking every transaction once again to make sure that, okay, the money that has flow out, or based on the financial, the organization example, the money that flows out to people should come back, okay? Or else they needs to check how much money they have spent and how much interest they have accrued and so on and so on. So there is a reconciliation process or audit that are being happening. That's why we need to record that in a ledger. Okay, then the trend has changed. People have started using information communication technologies, computers and all. Then they have the computerized or in a digital format. Okay, so can you name some issues if you think there are associated with the printed registers or a computerized account keeping systems?
So it can be altered.
Exactly, it can be altered. So think about a situation, okay? You are writing all the transaction on a register, okay? Sometimes some other people, other people in the organization came and tear off the paper, okay? So that may happen. So what about the other transactions that you have already written on that page? It has been lost. Even if it is in a computer system, right? And which uses the databases at the back end for recording this data, what will happen? If somebody gains access to that database, the data can be altered. For example, your friend is hacking in the database of that financial institution and making the entry as, okay, you have given 10,000 and your friend has changed or removed say 10, and that has become say 1,000 rupees. Okay, see, the data has been changed. So we need a mechanism where this data will be captured in a very tamper-proof manner. Nobody can change it. Okay, that is actually the blockchain. Okay, not only it will be recorded on a ledger, on a centralized ledger, the same will be distributed. What do you mean by distributing? Giving to all the persons. An exact copy of the ledger will be kept with all the persons. Okay, so that is why it is known as DLT, or distributed ledger technology. That is a foundation of blockchain. It uses a distributed ledger, meaning that copy of the ledger is with everyone in that network, okay, which is stored in a tamper-proof manner. Okay, that is blockchain. So a little bit of history, this also you might have seen from many of the previous sessions, but just to make you understand the history and to make sure that you are on track, okay, just see this slide. In 2008, okay, a document was published online which was called Bitcoin, a peer-to-peer electronic cash system by an unknown identity, Satoshi Nakamoto. Okay, so that was the early beginning, but okay, but listen carefully, the Bitcoin was not the first digital currency introduced in the market. Okay, but why Bitcoin became this much popular? Okay, so Bitcoin was not the first digital currency. There were a lot of digital currencies available in the market before. Okay, but Bitcoin has gained the momentum. Why? Any answers? Any guesses? Anything? Any random answers? Anything?
Due to
It
anonymity.
became popularity.
Popularity. Why it has become popular? Because the earlier digital currencies were facing some issues. Okay, the first and foremost issue it was, I mean, all those currencies were facing is called the double spending problem. Okay, the double spending problem. The second issue is the lack of adoption in businesses. Okay, there were some issues called the double spending problem. That's why the companies and organizations were very reluctant. They were opposing to use this. If nobody is using it, what is actually the use of currency? The currency will be lost. I mean, the value will be lost. That is what happened with the many of the previous digital currencies. Okay, so now we have heard a term, double spending problem. What is it actually? Double spending problem, what is it? You might have heard this term before in the session, I mean, in previous sessions as well. What is double spending? Anything? Any answers?
Multiple copies of the same transaction.
Okay. The currency that we have, the printed currency that we fiat currencies, right? So fiat currencies will not face the double spending problem. Why? Because, for example, you are going to the supermarket, you are buying something from the supermarket or from a shop. Okay, say you have purchased something, a book for 500 rupees. Okay, so you are paying 500 rupees physically, that is using the printed note to the customer, I mean to the shop owner, and in return the shop owner will give you the book or whatever goods that you have bought. Okay, now the question is, can you use the same 500 rupee note again for buying something? Can you use the same 500 rupee note that you have handed over to the shopkeeper for another transaction?
No, sir.
No, sir.
Because that is physically with the shopkeeper. Okay, that you have handed over that. You cannot take a copy of that note and initiate another transaction. Okay, so that is not the case with the digital currency. So the best example, the digital currency, example would be digital currency is something what is similar to the PDF file that you have in your computer. Okay, so your resume.pdf file is in the computer. Okay, you want to send that to the one employer. Okay, obviously you will be sending that. Sometimes you will be taking multiple copies of the same. Okay, multiple copies of the same and sending to multiple employers. Digital currency is like that. Digital currency is same like a PDF file that you have in your computer. You can create multiple copies and claim that you have multiple copies or multiple units of digital currency with you, and you can initiate multiple transactions. That will be a fraudulent one, right? That will be a fraudulent one. So the earlier currencies, digital currencies, were failed because they couldn't solve the issue of double spending. And in 2008, Satoshi Nakamoto proposed Bitcoin that could solve the double spending problem. How Satoshi solved it? Using blockchain. Whatever transaction you will be doing using blockchain will be recorded in a, using Bitcoin will be recorded in a blockchain in a tamper-proof manner using a decentralized ledger. Okay, where you cannot claim that you have multiple copies because the data is with everyone. They will be, if you claim that I have multiple Bitcoins, but if you only have one Bitcoin or something, the moment you say I have multiple Bitcoin, the people will object it. Okay, people will object. You say this is a fraudulent transaction. This person does not have this much balance, so the transaction will be failed. Okay, so in 2008, Satoshi introduced a paper. In 2009, actually launched the Bitcoin, okay, as an alternative to the current financial system, okay, and the notion of centrality has been taken out. Okay, notion of centrality has been eliminated. What is notion of centrality? There is a central person or a central authority who will be validating the transactions. Okay, who will be validating that. For example, if you want to transfer some amount of money from your account to your friend's account, who will be validating the transaction? Who will be allowing you to send the money?
The bank.
The bank, exactly. Very good. The bank. Bank is the intermediary, right? So we need to initiate the transaction. Obviously, that will go to the bank, and the bank will verify whether this person has this much amount of bank account. I mean, the balance is there in the bank account. Then only the transaction will be completed. But in Bitcoin or else in blockchain, the notion of centrality is not there. Okay, everyone is responsible for validating. All the persons in the network is responsible for validating. Or in more business terms, we can say, okay, the notion of centrality and the notion of trust Okay, we are trusting bank. That's why we are putting all our hard-earned money there, right? We are trusting. So the notion of centrality and the notion of trust can be taken from the organization level to the platform level. What is that platform? The blockchain. What is the beauty? The transaction will be recorded in a tamper-proof manner. Nobody can change it. Okay. So the notion of trust and notion of centrality is taken out from the organization to the platform, where we use mathematical and cryptographic principles to record the transaction in a tamper-proof manner. Okay, so 2008 published, 2009 it has become a reality. In 2010, actually, the first real world transaction in Bitcoin happened. Okay, so can you guess what was the transaction? Yes, it is given over here. It was just like buying 2 pizzas for 10,000 Bitcoins. Okay, they have actually bought, this was a commercial transaction, and they have bought 2 pizzas for 10,000 Bitcoin. Okay, so can you see what I have highlighted over here? What is it? What is it? 13,52,360.
Value of bitcoins in
Yes,
INR.
exactly. The value of 1 Bitcoin as on today. Okay, that is 13,52,360 Indian rupee. That is what the value of 1 Bitcoin today. So think about the transaction. They have bought 2 pizzas for 10,000 Bitcoin. So if you convert that into the Indian rupees, oh my God, that is a huge amount. Okay, so in 2019, okay, so there were a lot of other things happened in between, but in 2019, it was estimated that Bitcoin currently consumes 66.7 terawatt hours per year. Terawatt hours meaning that is the energy consumption. Okay, that is the energy consumption. If you are a part of a Bitcoin network, okay, you need to have some computational power. Okay, for utilizing the computational power, of course, you need electricity, right? So think about a situation, all the participants in the network are consuming electricity. They are running specialized softwares. Okay, their systems needs to be on all the time. So it is equal to the total energy consumption of the Czech Republic. This is one interesting statistics that has came out after a study. Okay, there was 10.6 million people living in Czech Republic. Okay, and the Bitcoin currently consumes the electricity, the amount of electricity that is equivalent to the total consumption of Czech Republic. Okay, so this is a bit history. Okay, 2008, Satoshi published the paper. 2009, they have launched it. 2010, actual the transaction happened. Okay, in 2019, people have started arguing, or they have started thinking about the environment, the electricity consumption and all. But anyway, if we think the potential opportunities of this technology, this energy consumption, everything can be minimal. Okay. Well, then what makes blockchain so special? I'm sure that you have seen many of these terms in the previous sessions. It is immutable. Immutable meaning you cannot go and change it. Nobody can tamper the data. It is tamper proof. Okay. There is a sequential chain with cryptographic hashing. If you check, these are called the blocks. Okay. These the rectangles are known as the blocks. Okay. So there is a sequential chaining. Chaining meaning the blocks are linked together. Blocks are linked together using some hashing mechanisms. Okay, the previous hash. So if you are from a computer science background, or if you have heard a linked list, you can better relate this with. Okay, the linked list will be having a collection of lists where each of this list will be linked to the previous one. Similarly, it is just like a train that is connecting the compartments. Okay, so there are blocks that contains the data, the hash of data, etc., and the hash of the previous block will also be stored here. That is how it will be linking, and the network will be growing like this. Okay, and there is something called a consensus-based transaction. What is consensus? Consensus meaning an agreement. In order to get a transaction permanently recorded onto the blockchain, there needs to have many thumbs up. What is thumbs up? Okay, I agree to the transaction. Majority of the people should say okay, then only the data will be written onto the blockchain, and once it is written, it cannot be changed. And there are many things like decentralized peer-to-peer network, distributed ledger that we have already seen, and there is something very interesting and very prominent that is known as self-executing smart contract, and we will be covering some details about this in this session. Okay. And how does a blockchain work? I'm not again going to repeat. Somebody wants to transact something, for example, they want to say send some money or Bitcoin or something, that will be broadcasted to the network. Okay, this is his node, this computer that will be sending the information to all the people which is connected. Okay, they are trying to solve some puzzle. Okay, just like solving some quizzes. Okay, for example, if I am asking you a question, how many letters are there in the word entrepreneurship? Okay, entrepreneurship. So that is the word I am posing to all of you. So there will be multiple mechanisms where I mean you can use to solve it. Okay, some of you will be just calculating the number of letters in the word entrepreneurship in your mind. Some of you will be writing that in a piece of paper and counting the letters and so on and so forth. But whoever proposing the answer first will be getting a reward. Say, I will be giving you 500 rupees. Okay, so that is the mechanism the blockchain will be implementing. So I will be posing the question to all of you. Similar to that, I will be sending the transaction to all of you. Then all of you will be solving some puzzles using some computational power, and then the answers will be sent for the verification. If everybody says, okay, this is correct, then the transaction will be committed. Okay, this is how the blockchain works. This is just like you propose some transaction, people will recognize those transactions, they will compute or they will calculate some something that is called the puzzle solving. Then once whoever finds the answer to the puzzle first will be sending the answers to all of them. If they all agree that okay, this is the correct answer, then the transaction will be committed. Okay. Then evolution of chain. Okay, you might have already seen this. The currency, the implementation of distributed ledger technology was the version 1.0. So if you check the evolution of chain or the blockchain, we will be terming it as blockchain 1.0, the 2.0, 3.0, and so on. Okay, right now it is 3.0. We classify them into 3.0. Okay, though if you check the 1.0, the famous cryptocurrency, the Bitcoin was classified here in 1.0. Why? Because cryptocurrency, the Bitcoin was introduced as a say micro finance platform, or else money sending and receiving platform. With the Bitcoin network, you can only send Bitcoin and you can receive Bitcoin. You cannot take Bitcoin network and customize the way that you want to perform. Okay, if you have Bitcoin, you can send to your friend. If you are part of Bitcoin network, you can receive the Bitcoin that will be sending, but you cannot implement the Bitcoin network in an organization to say to initiate the payroll processing, because Bitcoin is designed in such a way that it will only work for the money or Bitcoin transactions. But there are some evolutions that has happened after this 1.0 that is termed as blockchain 2.0, which is the most interesting term is here is a smart contract. Okay, there are blockchains that are classified into version 2.0 where they use a smart contract, okay, an extension of 1.0, okay, which we can write our own custom logic. For example, you can have a blockchain for your say accounting management, or for your healthcare management, or for your payroll processing. So you can customize the way in which that blockchain works. So those blockchains are known as blockchain 2.0. Okay, so can you say, anyone, can you say one example of blockchain 2.0? One famous example. Anything? Any answers?
Ethereum.
Yes, very good, very good. Ethereum. Ethereum is classified as version 2.2, because we can take Ethereum blockchain and we can add our own logic into it through smart contract. And 3.0 is the current trend. I mean, right now we are also practicing 2.0, and there are 3.
Sir, we could not hear you, sir. Excuse me, sir. Excuse me, sir, we could not hear you.
Sir, not audible, sir.
Yeah. Sir, we could not hear you.
Voice is not audible.
Dear participants, sorry for the inconvenience. Due to some technical glitches, we have to wait for 2 minutes. Please give us 2 minutes of time to solve this issue. Participants, please wait for a while. We are checking with the internet connection.
Am I audible now?
Yes, sir. Yes, sir.
Yeah, sorry.
You're audible, sir.
We got disconnected from the internet.
Yes, sir. I have conveyed to all the participants.
Yeah,
You may
yeah.
carry on, sir.
Yeah, sure. Thank you. Okay. So, am I audible? A screen is visible for you?
Yes, sir. Now everything is clear.
Okay, just a second. So I think the screen is visible for you now.
Yes, sir.
Okay. Sorry for the trouble, guys. We will be continuing. So we were discussing the evolution of chain. So evolution of blockchains, I hope I will be just repeating it. The 1.0, which was only for the Bitcoin transactions, because you will be transacting Bitcoin. The 2.0 is for smart contract, because you can customize the logic. 3.0 will be for decentralized applications, where you need to increase the speed. A lot of researches are being happening in the 3.0 sessions. Okay. So now let's see what is a smart contract. We have heard the smart contract many a times, and let's see what is a smart contract. So what exactly is a smart contract? Smart contract is actually help you exchange money or do some transactions or exchange anything of value, okay, in a transparent, conflict-free way while avoiding the services of a middleman. Okay, so in our daily life, we will be dealing with many a type of contract. Okay, the employer-employee contract, where we will be signing, after reading all those contracts, we will be signing. That meaning we are agreeing to the terms and conditions listed out there, right? So there is another situation where we will be buying properties. Okay, buying properties, where the person who sells the property and the person who buys the properties will come to an agreement. Okay, and they and the deed, okay, the agreement will be get registered under the registration department, which is by the government. Okay, so if you check the 1.0 version, there were no smart contract, and you cannot customize the logic. But with the 2.0, that is in the Ethereum and all the other blockchains, you can write smart contract and for customizing it. Okay, so let's check what is the difference between the traditional contract versus a smart contract. Okay, in traditional contract, see the parties, there is a contract. Okay, the agreement or the contract will be signed by these parties, and the third party, which is say the registration department or the motor vehicles department, if you are exchanging the vehicles, so and so, will be vetting, or they will be verifying the transaction, and then the deed or in the agreement will comes into effect. Okay, this is the way in which the traditional contract systems will work. Okay, now comes the smart contract. So what is smart contract? The contract that are in digital form, which will be executed based on certain conditions, that are known as smart contract. So in smart contract, what is it? The parties, the smart contract, and the execution. What is the difference between these two? A traditional contract and a smart contract? What are
The involvement of third party, sir.
Exactly, the elimination of third party. There is no need of a third party to verify the transaction. That is the beauty of the smart contract. This is how the smart contract will work. Okay, then benefits of smart contract. Let's see what are the benefits a smart contract will bring in. Okay, direct dealing with the customers. As we have just seen here, we can eliminate the notion of a third party. Then resistance to failure, because there can be some situations where the contract will be altered. The paper or a printed document can be altered. That is always the possibility. The fraudulent activities can happen. Okay, then the smart contract will be eliminating those issues. Okay, then immutability, it cannot be changed. Fraud reduction, the cost efficiency, the record keeping will become simple. I mean, if you are using a digital format. So these are the benefits of smart contract. Okay, so in technically, okay, from a technical point of view, what are the advantages of smart contract compared to a traditional contract? One is it is self-verifying. That is important. Okay, self-verifying meaning there are conditions that are listed out in a smart contract, and if some transaction needs to happen, then all the conditions needs to be met. So there is no person who needs to verify, say go one by one on each line and say, okay, this condition is not satisfied, this condition is satisfied, this condition is not satisfied. No, it is digitally done. So it is self-verifying. It is self-executing. What do you mean by self-executing? There is no need to you go and double click a smart contract to execute. It is based on certain triggers. Okay, it is based on certain triggers or conditions the smart contract will execute. For example, you can say, okay, if my account balance, you just for example, you are writing a smart contract, you can say when my account balance is more than 50,000, then send 10,000 to another person. That is a condition. So if your account is having only 25,000, no transaction will happen. Okay, but if you have say 60,000 rupees in your account, this smart contract will automatically executed by checking the condition, and 10,000 rupees will be sent to your friend. Okay, it is tamper resistant because you write a smart contract, you deploy that in a blockchain itself. You deploy the same, you keep the smart contract in a block itself. Okay, what is the advantage of keeping the smart contract in a block itself? What is the advantage? Why we should keep that in a block, or we put it in a blockchain itself?
Automatic execution.
Not automatic execution exactly, but this should not be changed, right? Once you write a digital contract and the multiple parties have agreed, okay, can you put the contract in a Google Drive? No.
It can't be cancelled at all.
Yes, exactly. So you cannot keep that in a drive. You cannot keep that in a database. If you keep in a drive or database, somebody can go and change the conditions. Okay. And once you write and deploy a smart contract, that will comes into effect. That meaning that is the contract logic that is going to work for all the transactions. Okay, so that is why we need to should be tamper resistant, and you should to keep that in a blockchain or a block itself. Reduces malicious or accidental events. Okay, that will be prevented. It is deterministic. What do you mean by deterministic? The outcome of the contract will be same for all the persons. Okay, whatever logic has been implemented in the smart contract, that will be applicable for all, and the execution result is also applicable for all. Okay, that is a technical advantages. And what is the economical advantages? It provides transparency, obviously. So the transparency meaning we will be trusting the platform. Okay, so the transaction can be securely done. It reduces intermediaries. There won't be any third parties to vet the transaction. Comparatively less transaction cost. So now you can imagine how much amount of money these intermediaries, say the registration department or any other departments, will be taking from us as an administrative or the transaction cost. If you are buying properties, okay, we need to pay a hefty amount to the registration department based on the or depending on the value of the property. Right. So those are the economical advantages, and now comes the legal advantages, or what is a smart contract in legal terms. Okay. So smart contracts can automatically execute, control, and document legal events, actions according to a predefined set of conditions. So we are buying the say properties, for example, the same example, and if right now I'm not giving the full amount. Okay, I'm just giving the advance. So those things can be mentioned in the smart contract. So, and say when I give the 100% amount, the digital copy of the registration document will be sent to me. Okay, so those are the conditions that you can impose that will be automatically executed. Nobody should be verifying if the condition is met. So if implemented correctly, they can provide more security for a contract. It is distributed. The parties involved in the contract are anonymous. What do you mean by anonymous? If you need to be a blockchain network, need to be a part of the blockchain network, you don't have to provide. Okay, you don't have to provide your personal information. Okay, so for example, if you are using a blockchain solution for your specific need, sometimes the registration department may need your identity proof and all, but in general, if you want to be a part of Bitcoin network, or if you want to be a part of a Ethereum network, then you don't have to disclose your information. You will be identified only with your address. Address meaning it is not the postal address, but it is a unique combination, unique value for everyone. Okay, so but there are limitations as well. Okay, so smart contracts can only be enforced upon digital assets. That is one limitation that the smart contracts will be having. You need to tokenize, or you need to digitize an asset. Okay, digitize an asset meaning the equivalent things should be converted into digital. Then only the smart contract will work efficiently. Okay, or else if you are physically going to exchange the goods or services, then the value or the actual purpose of the smart contract will not be met. Okay, so blockchain network is decentralized but not legally regulated. So that has happened with the many of the countries, and in India also people are very optimistic that some rule changes will happen, but it is not completely legally regulated. The interaction with the real world cannot be bound by the smart contract. That is another disadvantage. The enforcement of the smart contracts are some form of the if else. Okay, some form of if else can't implement very sophisticated variations. You cannot write a smart contract with very sophisticated variations of logics as you do in a say in a Java program or in a C# program. But these are the rules that needs to be written in certain orders and in certain conditions so that this will be executing. Okay, so these are the limitations of smart contract. So if you recollect what we have done, we have started with the Gardner, we have started with then we have discussed what is the blockchain evolution, then the way the blockchain works, then we have seen what is a smart contract. Okay, then we have seen what is advantages technically, legally, and the economical advantages of smart contracts, and let's see how we can create a smart contract. And before going to create a smart contract, let's see let's try to understand the basics. Okay, so solidity. What is solidity? Have you heard this name before? The solidity. What is solidity? Any answers? Am I audible to you?
Yes, sir.
Okay. So
Yes.
Solidity is an object-oriented high-level language for implementing smart contract. Okay. So we have many programming languages that we might have heard, like C, C++, Java, C#. Then there is ASP.NET. There is JavaScript. A lot of languages that we have seen. So, but for creating a smart contract, because the smart contract will be working different than that of a program. I mean, the actual Java program or C# program works. Okay, so Solidity is a language that is used for, it's a high-level language that is used for creating smart contract. Okay, so so it is created by a person called Gavin Wood. Okay, so primarily the Solidity language is used for creating smart contract for Ethereum. Okay, but there are other platforms which offers the customized languages for writing smart contract. But in this session, we will be learning the basics of Solidity. So Solidity is an object-oriented, high-level programming language, which is somewhat similar to JavaScript. We will see the code block. So at that time, if you are familiar with JavaScript, or if you have seen a JavaScript code, you can be relating better with the Solidity. Okay, so features of Solidity. Solidity is influenced by C++, Python, and JavaScript, and I mean, many of the features are borrowed from these languages. Its syntax is similar to JavaScript and designed to target the Ethereum virtual machine, or EVM. What is Ethereum virtual machine? Or what is JVM if you are from a computing background? Java virtual machine. What is it? What is a Java virtual machine? Or why we should use Java virtual machines? Any answers?
It's interpreter, sir.
It is not exactly an interpreter, but Java uses a compiler, right? So whatever code that you will be writing in Java language, when you compile the program, what is compilation? You are writing the program in high-level language, and that should be converted to a machine understandable format, right? So you are writing the Java program in a high level, that is in Java. Then the moment you compile it, what will happen? This will be converted into something called a object code. Okay, Java object code. Okay, or else that object code is known as bytecode. BYTECODE, bytecode. Okay, so what is the speciality of bytecode, or why we should convert the Java program, compile it, and convert into bytecode? What is the advantage?
It is cross-platform.
Yes, exactly. Yes, exactly. Good. It is a cross-platform. Even if you write a Java program and compile and convert that into bytecode in a Windows machine, okay, the same code will be working in a Linux machine as well. Okay, provided the Linux machine should have a Java runtime environment. Okay, it is a platform independent thing. Okay, similarly, Ethereum is also using a virtual machine, or called EVM. What is its duty? Whatever thing that we have written in Solidity programming language, when we compile it, it will be converted into object code or a byte code, which can be executed by any computers across the globe. Okay, so that is what Ethereum virtual machine does. Okay, so when we compile the Solidity program that we have written, it will be converted into bytecode, which will be executed by Ethereum virtual machine. So every computer or every node that are part of this Ethereum network will be running Ethereum virtual machine, which is capable of running the program that is converted into bytecode. Solidity is a statically typed language. The Solidity is also known as contract-oriented programming language. We might have heard procedure-oriented language, object-oriented language. Similarly, Solidity is also known as a contract-oriented programming language. Here, the focus will be on contract. Okay, it supports many features like inheritance, libraries, complex user-defined data types, etc. And this is how a Solidity code will be looking like. Okay, Solidity code will be looking like. So let's see what each of these lines denotes. Okay, so the first one is the SDPX license identifier. What is this SDPX? Software Package Data Exchange. This is a type of license. Okay, license. Okay, defining the source code license, under which license we are going to distribute the source code. That's what it means. Okay, then the pragma Solidity, this line, if you check the second line, that denotes the compiler version. As I have told you, Solidity has a compiler which will be converting that into bytecode. So the compiler version can be specified. Pragma Solidity, this symbol, you can see the point like 7.0, right? Is the code visible to you?
Yes, sir.
Okay, okay. So point
Yes, sir, it is visible, sir.
7.0, and you can see a symbol like this. This meaning this code will support all the compiler versions higher than 0.7.0. Okay, so this is the Solidity version that you need to specify in a contract, in a smart contract. Okay, obviously you need to specify the name for a contract, and the keyword is contract. Contract, then a contract name. For example, contract storage, or else contract your first contract, or contract your first smart contract, etc. You can give any name here. Then if you want to declare a variable, and this is known as a state variable. Okay, state variable, that meaning the values are permanently assigned to these variables. So u into 256, meaning this is an integer. We are going to store a number here. Then obviously, like other programming languages, the function will be starting like with a keyword function, then the function name, the parameter, then the visibility. This function is public, meaning it is visible to all. Okay, so what does this function stores? What this function does? Can anyone say? This function will save the value that we will be passing to a state variable. Which is the state variable? We have defined the state variable here. Clear? So the second function, we have a function called retrieve. Retrieve function name. Then there are no arguments or parameters. Then the visibility is public. Anybody can access this. Then there is a keyword called view. So what does this mean? This view keyword is not here. What is the difference between these two? Any wild guesses? Any guesses? Why we have used a view, the keyword view here, and we... Any answers? It can be, yeah, it can be guessed also. Yeah.
Selectively retrieve data.
Yes, yes. The view keyword denotes you are just extracting the data. You are taking the data from blockchain. Okay, you are not writing to it. There are two operations on a blockchain, right? One operation is you can write the data. Other is you can read the data. The write data, write operation will always cost a fee. Okay, the write operation, if you want to write some data to the blockchain, that operation will always make you spend some fee, the transaction fee. Okay, that is why we haven't specified here, because you are doing some write operation. You are assigning the number. Here you are just returning the number. You are not writing any operation. That is why you have used the keyword view. Okay, view means there is no transaction cost involved if you use the view keyword. Okay, so view keyword will be used when you want to retrieve the data only. When you want to write the data, you don't have to use the view keyword. So this is how a structure, or this is how the Solidity code. This is a very basic smart contract. Don't think that the smart contract will be like that. For example, if you implement that for a specific use case, the codes will be like 100, 200, 300, or even 2000 lines of code. Okay, this is but just a basic structure of a Solidity code. Okay, now the state variables I have already told you, the state variables are variables that will be stored values on a permanent basis. Okay, so is it audible?
It is audible, sir.
Okay, fine. These are the state variables. Okay, there are 4 type of users: the user, self, external contract, derived contract, etc. External contract meaning the contract which are available outside. Sometimes the contracts needs to communicate each other. Okay, so those are known as external contract. Okay, so these are the visibilities. If you declare a state variable as public, then user can see it, the self who has created the contract can see it, the external contract can see it, and derived contract can see it. So this is how the state variables will be accessed, or who can access what. Okay, then there are state variable type. As the type of data that we will be storing will be different. There are Boolean, integer, address, arrays, structures. So these are I mean the variable types that the most of the languages, the programming languages, will be giving, but Solidity is also giving. But extra there are certain variable types such as address, bytes, etc. as well. Okay, so then where the data will be stored, the data can be stored on a storage, memory, stack, etc. These are the storage type. Okay, where you can store the data. Then Solidity functions, we have seen the function will be starting with the keyword function, then the name of a function, then the parameter, then you need to specify whether the function should be public, meaning visible to all, or it should be private, visible to the internal or external, etc. Okay, so these are the functions. Then the function modifiers. Okay, as I've seen, the public, private, internal, external. So these are the modifiers, meaning how you are going to present the function to the outside world. Then the Solidity functions accessibility is also here. If it is public, it can be viewed by all: user, self, external, derived contract, etc. Okay, then the Solidity control structures like if, else, while, do while, for, loop control. So all these are similar to the other programming languages as well: loop control, break, continue, etc. Okay, then the development phases of a smart contract. So we have seen the basic structures and basic constructs of a smart contract, and this is the development phases of a smart contract. Okay, so what are the development phases? Okay, one is the product roadmap, meaning what needs to be developed. Second is the usability research. Okay, you have to identify the usability, whether this should be solved by a smart contract or not. Then if it is solvable by smart contract, you need to have the architecture design, then the development phase, then the testing. Testing is very important in smart contract, and the third party security audit may also be happening. Then the bug needs to be fixed, and then you will be finally deploying it. So trust me, developing a smart contract and deploying that in a network is not an easy task. It is not simple as that you write a Java program, compile it, and deploy it. No, this involves a very complex procedures. Okay, can anyone say why we need to be following these steps while developing a smart contract, or why we should be very vigilant for developing and deploying a smart contract? Why?
Because it can't be edited after the final submission.
Exactly. Once you write a smart contract and deploy that in a network, the transaction will start using the smart contract, right? So it is not just like you debug a Java program, recompile it, and deploy it. So once you deploy it, it will be written onto a block. You cannot go and change the smart contract. So you need to be very vigilant while you develop a smart contract. Okay, so the deployment phases can be classified into these. One is the initial deployment. Once you write the code, you will be compiling the code. So compilation will give you two things. One is bytecode, that I have already told you. Bytecode is an object code which is run by the EVM, Ethereum Virtual Machine. And ABI meaning application binary interface. ABI, application binary interface, meaning ABI is used for accessing the functions inside the bytecode, or the functionalities inside the bytecode. Okay, this is the two things that you need to keep in mind. while you deploy the Solidity or the smart contract, the bytecode and ABI. Bytecode is object code, ABI is the interface that is used to access the functions. Okay, so enough theory now. So let's see how a simple smart contract will work. Okay, how a simple smart contract will work. I will show you how a simple smart contract and how that is being developed. Okay. So you don't have to do this in parallel. I will send the instructions later on how to do it. Okay. So there is an online IDE. Is the screen visible, sir?
Sir, it is visible.
Okay. Okay. So one thing that you need to understand is there is an online IDE, okay, which is called a Remix, which is used for developing smart contract. Okay. So if I check this, okay, so remix.ethereum.org. Okay, remix.ethereum.org is the website address. Okay. So this is online. This is available online. You don't have to install anything. Okay, this is the interface. Okay, so once you get this, it will be like remix.ethereum.org. Okay, you can go there, and it will be having multiple parts. One is the file explorer. File explorer is a place where you, where the files created by you will be listed. And here is one part where you write the code. And here is something that will be showing the statistics. Okay, so there are three parts: file explorer, the code that you will be writing over here, and then you can see the statistics as well here. Okay, and if you want to say create a new contract, here you can see a plus sign. You can click it. Okay, that will be creating a new file. The extension of Solidity file is .sol. So similarly, like if you are writing a C program, the extension would be .c. Okay, if you are CPP using CPP, CPP would be C++ would be CPP will be the extension. And for example, you can give a name. For example, I can say the first contract.sol and press OK, and that will be created here. First contract.sol. Okay, and let's take a simple example, the same example that we have seen before. Just copy the code. Okay, just paste it here. Okay, so what does this, if I ask you, what does this pragma say Solidity, this line will tell what is the use pragma Solidity. Can you recollect?
Their compiler version.
Yes, compiler version, exactly, compiler version. Now I am defining a contract here. Contract name is storage. It is having one state variable called number, and I have two functions. One is to store the value, other is to retrieve it. Okay, this is my code. Very simple smart contract. Okay, simple contract to make you comfortable with the writing a smart contract. Okay. So I have written the code. What would be the next step? I have written the code. Then what would be the next step?
Compile this code.
Exactly. The code needs to be compiled. So there is an option here. So if you check here, the second option is Solidity compiler. So you can check this. Okay, so that is showing the compiler version. I have mentioned 0.7.0 and here the 0.7.4. That meaning 0.7.0 and greater versions will be compatible. That is what it means. And the language is Solidity. It has been chosen Solidity because we are learning Solidity now. Okay, then there is an option for auto compile, because as and when you write or modify the code, there can be you can enable this to make the code automatically compile rather than you go and press the compile, but we haven't enabled it. You can optimize the code by checking this one. You can hide the warnings produced by the compiler also by this. So there is a message, no contracts compiled yet. So we are going to compile. So there is a button called compile first contract. Okay. So compile the contract name. Okay. Just to press the compile. Okay. On clicking the compile, you can see a checkbox. You can see a tick mark here. That meaning this compilation is successful.
Okay, compilation is successful. So after compilation, what are the two things that will be generated? Can you recollect? Can anyone say what are the two things that I have mentioned?
One is object and another bytecode.
One is object and the next is? One is bytecode and another is ABI, application binary interface. Right? ABI, application binary interface, and the bytecode. Okay, let's see what is the bytecode. So this has been generated on compiling the first contract. ABI and bytecode is generated. Let's see how the ABI look like. Okay, so I'm just copying the ABI. Okay, I am pasting the same somewhere. Okay, so this is how the ABI will look like. Okay, this is how the ABI will look like. So this is how the ABI will look like. Like it will be having a JSON format. Okay, there we're having two functions, and the two functions and other details will be here in the ABI. The ABI is used to call the functions. Okay, so there is a bytecode as well. So let's see what is the content of a bytecode. Okay, I'm copying the bytecode. Okay, and see the bytecode. Can you read something from the bytecode?
No, sir.
Why? You can obviously read this generated sources, link references, etc. But the actual object cannot be read. Okay, this is somewhat similar to the assembly level language, or when you write a high level language program, you compile it, that will be converted into low level language for the machine to understand and execute. This is somewhat similar. You cannot call or you cannot read the functions from this one. This will be having some instruction: revert, return, call data size, push, jump, etc. Okay, so this is what I meant by the object code. This object code is executable by all the computers who have an Ethereum virtual machine or EVM. Okay, so we have written the first contract, we have compiled it, we have generated ABI and a bytecode. Okay, now I am going to say call the functions. So before that, I need to deploy the transaction. What do you mean by deploying the transaction? Deploying. You are putting the smart contract. You are putting the smart contract into somewhere. Okay, you are putting the smart contract into the blockchain. That is the meaning of deployment. So there is a deployment button over here, the third option in the remix. Okay, so deployment. So let's see what are some of the options. You don't have to be nervous that you are not understanding these things, but once you go through the IDE, you will be able to understand these things. Okay, there is an environment, JavaScript VM. Okay, that is a default selection, and there are accounts. So accounts in Ethereum is somewhat similar to the accounts that we have in the bank. Okay, there is an account number and the balance. Those are the things maintained by a Ethereum account as well. Okay, here if you check, by default there will be some accounts that are pre-filled by the Remix Ethereum IDE. Why this should be pre-filled? Which are having 100 Ether. What is Ether? Ether, the cryptocurrency in the Ethereum network or the blockchain network. Ethereum is known as Ether. So these are demo Ethers. You cannot encash these 100 Ethers. Okay, these are for the demo purpose. These are for the testing purposes. You cannot encash it. Okay, so you need to have an environment. You need to have an account with the balance. Okay, there are other parameters as well. Now I am going to deploy it. Deploy meaning I am going to publish that in a network. So there is a deployment button. Okay, press the deployment button. The contract will be deployed. Okay, the contract will be deployed. So if it has been deployed, there is a arrow something like this, the storage at something. This is the contract address that we have. Okay, the contract address. There are two options, store and retrieve. What is this store and retrieve? Those two buttons. What is it? Store, retrieve.
Store is
function of a program.
Those are the function names that we have written in the code, right? The function store is here. The function retrieve is here. So what is it actually done? It has created two buttons store and retrieve. Store is having a text box here and a place for entering the value, but retrieve does not have it. Why? Why?
Because we are taking the input in the store function.
Yes, exactly. What does a store function do? Store function is assigning the value we will be giving to a state variable called number, but retrieve function will not be taking any argument. Here the argument is empty, right? So that is why we don't have a text box here. Okay, let's execute the store function. What is the duty of store function? The store function will be storing a value. Let's say I am giving the value 200. Okay, I am giving the value 200 and press the store function. Why this store function or the store is shown in orange color or in this color is meaning, okay, we are going to write the data and some transaction fee will be taken. That is the meaning. Okay, retrieve is just to view. That is why it is displayed in a blue color. Clear? If there is a transaction that happens, that is to write the data, then it will be displayed in a red color. If it is a view, that will be displayed in a blue color. Okay, so let's see. I'm going to set the value 200 to the variable. So 200 I have entered in the text box and press the store. Okay, so once you press the store, a transaction has been initiated. Okay, so this is the transaction. See this? This is the transaction. If you check this one, okay, a transaction has been happened. Okay, transaction mined and executed. Transaction hash has been generated. From account to account, everything has been generated, and these many values has been deducted as transaction cost, and these many values has been deducted as execution cost, etc. All the statistics about the transaction will be listed here. Okay, so now the transaction has been done. So earlier, if you check, we were having 100 ethers here, right? Now it has become 99.99999 so on, so 850657 ether. What has happened here? What has happened here? Any guesses? We were having 100 ethers, but after the transaction, after I called the store function, it has reduced it to 99. What has happened? Yes? Exactly. There is a transaction charge, right? There is an execution charge that needs to be paid, that has been deducted from my account. Okay, a small transaction fee has been deducted. That has it become 99.99. Okay, so I have stored the value 200. Now I need to retrieve. I need to check whether the state variable is having the value 200 so that I can press the retrieve. Okay, if you press the retrieve, it will be printing the value uint 200. So what is this 200? This is the value I have set for the value or the state variable number, and I am retrieving the value using another function retrieve. So this is how you write smart contract. Don't think that you can only play with Remix IDE. Okay, no. All the professional developers, most of the professional developers will be using this one, the Remix IDE for that. Okay, so when you press the retrieve function, that also a transaction has happened in the blockchain. Okay, so so values, so decoded output is also printed, which is equal to 200. So 200 is the value that we have set in the state variable. So don't get nervous or scared on seeing all these things, but take baby steps. Okay, first you visit remix.ethereum.org. Okay, where you just try or get your hands dirty working with some of the controls and all. Then I will send you this code, okay, or else I will be sharing the slide in which you can have the code. You just paste the code and just compile it and deploy it and play with it, okay, so that you will come to know how to write and deploy a smart contract. Then you can learn the advanced smart contract.
Madam Vijayalakshmi.
Okay.
Madam
Sir, I've got a doubt,
please
sir.
Yeah, just a second. Let me conclude with one more slide and I will then clear your doubt. Okay. Okay, so there is one more slide that Solidity best practices. Okay, best practices meaning the things that you need to keep in mind when you write and deploy the Solidity smart contract. Okay, first thing is write clean code and keep contract simple. Simple meaning don't declare unwanted variables, because that will cost some transaction fee, that will cost some memory. That is not a good practice in the Solidity. Okay, so keep the right clean code by commenting the code as well, but keep it simple. That is the first strategy. The second is good test cases. What is test case? What is test case? What are test cases? Am I audible?
Is it exception
Yes, sir, you're
handling?
audible, sir.
Yeah. So test cases are just like we are confirming, we are making sure that all the functions are working properly. Okay, all the functions are working in the same manner that we expected. So we need to do a lot of testing on top of it, because the moment you deploy the smart contract, that will be written into a block and you cannot go and change the variable. For example, so rather than putting a plus symbol, you have put a into symbol, so that the two values will be multiplied rather than added. So that is a complex bug have in your smart contract. You cannot go and change that dynamically. Okay, so test cases is important. Then use of dynamic variables needs to be very vigilant here also. The variable type like strings and bytes, it will be occupying a large memory, the data types. Okay, always fixed size variables like bytes 32, bytes 30 needs to be used. Okay, so bytes 256 meaning you are having unsigned integer that you will be storing 256 values. So I mean, please be very sure that you declare the variables as and when you only want it. The unwanted memory leakages should be avoided. Then the arrays. So you always prefer fixed size arrays over dynamic arrays as and when required. But if there are dynamic arrays required, you can declare it. But if it is only necessary, you may declare the dynamic arrays. Then the memory caching. Instead of performing operations on state variables, do it on local variables and then assign all those values at once into the state variables. State variables are the variables that is used to store the values permanently. Okay, then the access restriction. So obviously when you deploy the contract, you need to specify who all can access the smart contract. That is important, or else some external parties will be accessing your code and will be doing some things, like some initiating some transactions, and also access restriction should also be implemented. So now always it is a good practice to lock pragmas to specific compiler versions. As I have shown you in the code, pragma Solidity is equal to set it to a specific version and higher on, or else your code written in the higher versions will not be compatible with the lower versions. So these are the things, some of the best practices that you need to keep in mind. So I think I have given you a very brief idea on what is smart contract, some of the access specifiers of smart contract, its legal, economical, technical advantages, and also most importantly, the remix. I'm introducing you the remix IDE, which is available in internet. You don't have to specifically install anything in your computer. You can go and write your smart contract, start playing with the smart contract online, then see how the deployment, compilation, everything works. And that is it from my side. Thank you for listening, and thank you so much for being so attentive. Thank you so much. I hope that you could learn something from this session. And in my personal opinion, it doesn't matter whatever theories that you will be learning, always try to execute something as your learning outcome. That will be helping you in long run. Okay, so thank you so much and have a great evening. Thank you for joining.
Thank you, sir, for the words of the wisdom. And all the participants have enjoyed this session. And thank you for making the session very, very interactive one, because the session was done in the afternoon. So thank you so much, sir. Now let me welcome Ms. P. Jhansi Rani. And before that, I request all the participants to provide a feedback. Participants, anybody.
Good evening, sir. My name is Gagana from Central University of Tamil Nadu. It was very interesting to know that upcoming the generation, what we have to know about the contracts, which was physically handled before, but now it is through the a blockchain which will be engaging, and in future, as you have explained in the history, how it was and how it has grown, and in future 1 decade, in 2030, how the proportion will be changing, how we have to adapt for the upcoming businesses. And it was so informative, and thanks a lot for giving us time to teach us, sir. Thank you.
It was my pleasure. Thank you.
Thank you, Gagana. And dear participants, if you have any questions or queries, you may post it right now.
See one question from Kalai Kannan. Will there be any execution charge for each and every contract execution? Yes, that's what I told you. If you have to write something, so like if you want to deploy the contract itself, there will be some transaction charge that will be taken from your account. Okay, because you are doing a transaction of deploying a contract. For that also some amount of the values will be taken from your account, plus whatever be the functions that you have written that will be writing data to the blockchain will also consume it. So unless you specify the keyword view, okay, all those functions will that are trying to write the data into the blockchain will take a transaction charge. That is the answer to that question. Okay, Vijay Lakshmi, you can shoot your questions now.
Thank you, sir.
Sir, I have got a doubt, like the transactions that are already completed and validated and verified will get inside the block. And
yes,
what if the participating transactions get aborted or rollback of transactions takes place? How the synchronization is ensured, like?
So to reframe your question you were asking, like you have initiated a transaction and the transaction has not committed, right?
No, it has already committed,
okay,
and got inside the block. It has entered the block, like.
Okay.
After entering the block, in future, suppose some rollback or some abort happens.
No, I mean, if you have initiated a transaction and the state has been changed in a blockchain, there is no like aborting the transaction or changing the transaction. Okay, that is what I told you. It is not just like you update a database, because you need to have a consensus mechanism, right? Whatever things that you need to be written into a blockchain, multiple parties, the majority of the participants needs to agree on that. Okay, so if that that is not a correct transaction, then there will be some objections. In that case, that will not be written, and if it is written in the block, there is no like a rollback or something in a blockchain.
Okay.
Yes.
Thank you, sir.
So another question, Abhishek Anand. Yes, Abhishek Anand. Is there any another IDE other than Ethereum? There are plenty of IDEs available right now. Even though, like IDE, I mean, why I suggest this remix IDE is that everything is in one place. Like you can test it with accounts, you can compile it, you can deploy it, you can see the statistics, everything. But there are people uses other IDEs as well. But I personally suggest you to use the Remix Ethereum IDE, but extensions are available for Ethereum deployment and all with the Visual Studio IDE and all those things as well.
Thank you, sir.
Okay, sir, why more electricity consumption in blockchain? Yeah, obviously there is a process called the transaction needs to be verified. Okay, or else there are the terms of miners. Okay, so miners are the people who will be using sophisticated computing platforms or sophisticating hardware platforms to mine the block. Why they should mine? Because they needs to solve the cryptographic puzzle, right? So why they should do that? In return, if they are proposing the correct solution first, okay, in return they will be getting some bitcoins. So all people will be competing. So what will happen if all the people are competing? Whoever having the highest computational power will succeed. Okay, whoever will be having the highest computational power will succeed. So people will add more and more computational power to their computing system, right? So adding more and more computational, meaning it will be consuming a lot of electricity. So in earlier days, if you check, even if you were having say one laptop or something, right? During 2009 and 10 and all, if you were you having a simple laptop and all, you could have mined bitcoins, but that is not the case now. Now the situation has been completely changed, and there are mining pools, POOLs, okay? The mining pools where people will be joining, because the probability of you getting a bitcoin, okay, if you are sitting with a laptop, will be very, very less than you use a GPU machine or a collection of GPU machines. Okay, so think about a GPU machine consuming the power running 24/7 into 365. Similarly, across the globe, people are using some, high computational powers, and that's why the electricity consumption will be very more.
Sir, participants, you may ask the questions directly. Participants?
Yeah, there are, I think there is a couple of questions in the chat as well. So can I answer that as well, Sundar sir?
Okay, sir. Okay,
Yeah,
sir. Please go ahead.
they have already put the chat, I think. Okay. So from Jitendra Goyal, can we feed data from IoT enabled Arduino to Ethereum? Of course, you can do. That's what I told. The Ethereum, not the blockchain will not be in isolation. So you can treat the blockchain as a data capturing platform where the notion of say the centrality is not there, or else it will be recorded in a tamper proof manner. Okay, so the data does not matter from where it is coming. It can be a the simple data entry form, it can be a sensor data generated from the IoT devices, but what does this matter is like how you capture the data and how the transactions are initiated. But IoT, there are specific data, specific blockchain platforms designed for IoT operations called IOTA. So those are the blockchains specifically designed for IoT operations. Because the sensor data that is being generated from the IoT devices and sensors will be much more in quantity, right? So the transaction cost will be much higher in Ethereum, or if you use any other say blockchain. So there are dedicated blockchain platforms available to deal with these type of situations. Okay, so Ashok Kumar, sure sir.
Let me request the participants to queue. We need 2 more participants to give the feedback.
Okay.
Here, participants, anybody
can voluntarily say and
Yeah, sir.
yes, madam.
This is Shalini Yadav from Jaipur, Pune University. Sir, this was a very nice session. This is my feedback, and actually that I'm working on that programming concept base. So this is for more efficient working for me on work on this blockchain easily with the Java code. So as a programmer, this is good enough for me to work on this blockchain easily, and to getting understand with the smart contract and the concept of this term you are using Java code over there. So I'm happy to write a code over Java on smart contract. Thank you so much, sir.
Thank you, ma'am. Thank you so much.
Thank you, madam. Any other participant is willing to give feedback about this session? Any other participant? Okay. Thank you so much, madam. Thank you, sir, for our wonderful deliver on the contract, this smart contract. And now let me welcome Madam P. Jhansi Rani to deliver a vote of thanks.
Thank you, sir. It has been our pleasure to host all the participants of the FDP. The participants were very enthusiastic. I am thankful to all the participants for attending the FDP. We have been fortunate to have some of the eminent persons from academia and industry. Our guest for the afternoon session, Dr. V.S. Anup sir, was so informative and practically as well as lively. We are all inspired by your great words, sir. Thank you so much, sir, for that. I thank our HOD, sir, faculty members, and research scholars of our department, heads and professors from various departments of our university, and above all, enthusiastic participants. Once again, I thanks to all. Thank you so much.
Thank you so much, ma'am.
Hello.
Hello. Dear participants,
if
just a minute, Raghu, just a minute.
Yeah,
just
yeah,
an
yeah.
announcement.
Yes.
The assignment questions for the day 2 will be mailed to every one of you by now. And as expected, as informed yesterday, you are expected to submit it on time by tomorrow within 10 a.m. Thank you. Raghu, over to you.
I can see some questions are left unanswered actually. So if anyone want to stay, we'll keep it open, keep this window for next 5 minutes. If someone wants to ask question or if someone want to interact with Anup sir, they can interact for next 5 minutes.
Yeah. Like I will be sharing the slides, or else be sending the email address as well. So like you can send the questions to that email as well. I will be happy to answer.
Hello.
Yes, ma'am. You can pose your question, ma'am.
Yes, sir. Sir, suppose the blockchain is susceptible to internal attack, or it is like a miner becoming a hostile and turns to disturb the underlying fabric. Like, is it possible, and what are the solutions to that 51% attack? Like,
Yeah, I mean, that chances are there because we cannot say that, I mean, it is anonymous, right? The property is anonymous because we don't know who all will be joining the network and all. But there is some process called I mean, for example, if I am an anonymous node and I am a hostile and I'm completely disturbing all those things, okay, the transactions, or I'm sending the invalid responses to consensus. But for some period, I can be like that. Then after that, all these other parties will be forming a consensus to eliminate myself, or else the blocks produced by myself will not be evaluated. That is the strategy used by the blockchains. Okay, so whatever things I will be proposing will not be taken account into the account. I mean, taken account into the network. Okay, the others may come to like downvote me, so that after sometimes my credibility will be lost from the network, and I will not be able to propose anything to the network.
that means it will be blacklisted. Like,
Yes, that is possible. Yeah. And I have already shared my email address in the chat box. And if somebody wants to ask some more clarification or any resources related to blockchain or something, you can straight away send me an email. I'll be more than happy to help.
thank you, sir.
Thank you so much. Thank you. Lakshmi, I have already sent the email address. It is anup@rajagiri.edu. You can send your questions over there. Thanks.
One last question, sir. I want to pose on behalf of Shilpa Agarkar. She's asking which is IDE for Hyperledger Fabric, sir?
For Hyperledger Fabric, I mean, for Hyperledger Fabric, I know the developers are using, say, the Visual Studio Code. There are some extensions that needs to be enabled. Okay, so there are some extensions that are available in those IDEs, and you can enable that, and that will help you create the fabric codes. I mean, the Hyperledger Fabric code. You can use the Visual Studio Code IDE Visual Studio Code, which is freely available. You can download it from the internet, and you can enable some extensions so that it will become it will be suitable for to write the chain code or the codes in a fabric.
Okay, sir. Thank you.
Okay, thank
you. I hope everyone's query has been addressed.
Thank you. Thank you for all your feedback. Okay. Thank you for the responses. Thank you so much.
Thanks.
Thank you, sir.